happens when you type print hello PyLadies, or basically a talk where we're going to have a little small look into some Python internals. If you would like to follow along with this talk, you can find the slides at bit.ly/IWD-L Mesa. Real quick note on me, my name is Lorena Mesa, my pronouns are she, her. I do a few things in technology, including apparently making avatars with Python plushies. I help manage PyLadies Chicago, founding organizer, and I've been doing that for the last 5 or 6 years. I'm chairperson and director of the Python Software Foundation. Work at GitHub in my day job, and I'm an editor with the Journal of Open Source Software, amongst a few other things. Favorite topic of mine is discussing responsible computer science and responsible practices in technology. So let's get started. First, when we talk about Python, us as Pythonistas, we know that Python is an interpreted language, but what exactly does that mean? You may have seen a graphic like this before, talking about how we start with working in our text editor, where we will be writing, for example, our .py or .py extension source files, but how do we go from there to actually having running code? So when we actually write our Python code in our source files, what we do then is we then pass those source files off to the Python interpreter. So let's say I have a program called main.py, and maybe in main.py, I've got a db.py and a utils.py, as this is a program that's doing something with storing some data in a database file I call db.py, and then I have some reusable code that maybe a few of my modules will need, and I put that in the utils.py. When the main program is running, the Python interpreter is going to first compile the code, which then creates that bytecode and then passes it off to the virtual machine. You'll notice here that the library modules will be actually dependencies that are installed if they're not part of the Python standard library. But all of that interaction of taking the .py files and then translating them to bytecode, the extension pyc files, that's actually handled by the Python interpreter. So when the Python interpreter runs and it creates, sometimes you might have seen like a dunderpy cached file with files that are named .pyc, that's what the Python interpreter is generating. And then the virtual machine will run those files so that we have our running code. So now that we've looked at a bird's eye view, a little bit of what it means when we say Python is an interpreted language, let's dig in a little bit into understanding the creation of Python bytecode. So the very kind of simplified flow that we have here, we're going to be writing our Python code in the .py files. Those files then will then be tokenized. Specifically, if we have expressions like x equals 1 plus 2, let's say that happens on line 1 of our file, what the Python interpreter is going to do is it's going to go ahead and actually find the expressions that make up our program and then treat them as and find these tokens. These tokens then are parsed into an AST, an abstract syntax tree. We then take the AST and we compile the AST into bytecode. Again, remember that's those .pyc files. We then pass the bytecode to the interpreter, and then we interpret the code, which is what the virtual machine is doing when it actually executes the bytecode. Basically, we can think of the virtual machine as acting like a stack, where we're going to be pushing values on, that is the tokens that have been parsed into the AST and then translated into the bytecode. So we'll be pushing values on, reading those values, computing some values, and then we're going to pop them off when we are ready to return a value back. So we then pop those values off the stack, which is how we're thinking of the virtual machine. So we've talked a little bit about how Python is an interpreted language. We've talked a little about some of the flow of what happens when we actually take our .py files and then actually go and try to generate the bytecode to actually run the actual code. So let's take a look at the process with a small example. You'll note that this code here actually is borrowed from Stefan's EuroPython 2016 talk, exploring our Python interpreter. He is really, really good at going in and talking about core Python development about where to get started, how to understand what ships with Python when you actually go and download it. So this code here, specifically, if you want to view that talk, I've included the link here and I have a resources slide. But this code is also available on a GitHub repository I've made available called IWD-PyLadies-Mesa. So taking a look here, what you can see is we have a tokenized module, we have the dis module and the AST module. So if we were taking something like the print hello PyLadies string, where we have our built-in function print and we provided a string, if we were to store that in, let's say, a script called hello.py, we can use the tokenizer to see what kind of tokens then we would get back when the tokenized mechanism runs. Then on lines 19 here, we will see to 21, we see how then we take that Python code, again, that print hello PyLadies statement, we then will turn it into an AST. We then compile that AST into the compiled code object at line 21. And then we see on line 24 and 25 how we take that compiled code and actually use the dis module to go ahead and generate our bytecode. So that's actually going to give us some output like this. So if you see when we tokenize, what we see is that we get name, the string print. We see that another token info that we get is the actual command print with the hello PyLadies string. Then we actually see the string itself, hello PyLadies. So this is some example of some of the tokens we see. And then when we actually, if you recall on this slide on lines 24, 25, when we're actually we've now actually populated the AST, we've compiled it, and now we want to go ahead and generate that bytecode. This output here, where we see the load name, load const call function, that output is actually going to be the commands that the Python bytecode will actually generate. And what's pretty nifty about this, if you wanted to understand what happens when you're actually using Python and you want to see that bytecode get generated in real time, there's a really nifty way to do that. So first things first, you're going to want to install Python in debug mode. On the GitHub repository, I've linked to some documentation talking about how to install Python in debug mode, but essentially we'll be installing Python from source. Once you go and grab that, we're using 3.9.2, the latest and greatest. We can go ahead and configure, notice that flag we pass in with the with PyDebug flag. Then we're going to go ahead and make it with the PyRef debug C flag specified, and then we'll go ahead and make install that. Then when we are in our machine and we say Python, we'll see that indeed we do have the 3.9.2 configured and installed. And now we can actually set the L trace. If you're within the Python interpreter, if we set that to none, now what we're able to do when we actually say print hello PyLadies, we now actually get to see the bytecode. So we see the function, we see that how it's pushing in a value of the hello PyLadies string, and then it will go ahead and actually use the built-in print on the provided string. And notice then we get a none value back, since when we print a standard out, we don't have any value that's returned. So why should I care about doing this? That's a great question. And let me suffice it to say that understanding Python internals has many benefits. It can help you get started on becoming a core Python developer, which is awesome. We would love to see more PyLadies. And I know Marietta, for example, is an amazing inspiration for how we can all go down that path. It can help us just understand what the Python interpreter is, and maybe help you get started if you're doing your own open source project. As I promised, here's some resources available for you should you want to continue this learning, including Stefan's talk, the structure and interpretation of computer programs, which is a great read. You can see the lectures online or even take the MIT course with that on this topic, where you get to learn to write your own compiler and kind of talking more about that very generalized, very simplified idea of what the virtual machine is. David Beasley does a great offering and a deep dive on the structure and interpretation of computer programs. He does actually do it online, so you can check that out. And of course, you can go look at the Python Dev Guide to help you learn how to do CPython setup and just learn more about CPython development. I'd like to thank you for attending my for virtually attending my talk. If you have any questions, or if you like this slide stack, I think it's a cool one. You can reach out to me on Twitter. And as mentioned, I will also, you can also look at these slides with the bit.ly link that is found on the title page for us today, bit.ly/IWD-L Mesa. So for this year's International Women's Day theme of choose to challenge, I am hoping you all are choosing to challenge yourself by learning more about Python internals.